Today we are going to study functions and M files.
Hello, I have a question.
Yes, please.
You saw me.
Pardon?
You saw me.
Oh,
Is 256-bit encryption state of the art?
I'm not really sure about the encryption techniques. I'm not sure. Why?
Well, on the weekend I was stabbed with a knife by a prostitute. It's a
Okay,
long story.
later. Okay, so let's start this lecture. I got a little bit late because I could not find the parking today. So I parked the car really far away. Any questions related to the previous lecture?
Excuse me, how many lectures have we had since I was here last?
So every week we have 3 lectures. I don't know when you were here last.
Did I miss 2? You should know.
There are 200 students. I don't remember everybody. This week we had 1 lecture, then we had 3 lectures last week.
How many have I missed?
I don't know.
I want to
Maybe.
know because I need to know how many pages.
I'll calculate them for you after the class.
6, 12?
So we have already seen the built-in functions in MATLAB. We did study a couple of them in the last lecture. Today what we are going to do is that we are going to write our own functions. And before you delve into writing your own functions, you should be motivated enough to write the functions.
Have you covered sort yet?
Pardon?
Have you covered sort yet?
I did sorting.
What sort of sort?
Did selection sorting. You can ask these questions after the lecture because I'm already short on time.
Covered IBM's DF sort yet?
No, we don't have to cover that one. Okay, let's get back to the lecture. So I was telling you that you need to be motivated enough to write functions. So what could be a possible reason to write functions? The most important one is reusability. If you want to reuse your code again and again, you can write that code as a function, and then all you need to do is to call that function. For instance, let's take the example of the default functions in MATLAB. For instance, taking a determinant or an inverse.
What about the memory?
Pardon?
What about the
So no more questions now. Ask questions after the class.
reusable memory?
No, we are not talking about reusable memory here. Right, so for instance, if you want to call the determinant function, all you need to do is that you need to write the name of the function, and then you have to give an input to the function, right? But in the last class, I showed you.
Get mine on IBM.
Right, if you don't want to study, you can leave the class.
I do.
I told you no more questions now.
I want to study.
So no more questions. Ask me questions after the class, please, sir. All right. So, but if you have to calculate the determinant over and over again, it would be tedious to write all those lines. That's why that MATLAB function provides you a very easy way to do complex calculations. Similarly, if you want to call the same code again and again, you can write that code in a function. So you can break a problem into manageable, logical pieces. Okay? And then there is another thing, that if your code gets too long, like there are thousands of lines of code, that's hard to read. So your code should be readable. And if you have your own functions written into separate files, you can call them whenever you need them. So what's going on here is that a function M file is different from a script M file. So I just mentioned that you can write functions into different files and call them. And then you have already done that in your practicals and tutorials, that you can write your code into a script file, and you name that file yourcode.m, and that's a script file. But a function M file is a little bit different from that script M file. So function M file communicates with the MATLAB workspace only through specially designed input and output arguments. For instance, when you want to calculate mean, let's say you have 5 numbers, 1, 2, 3, 4, 5. And if you want to calculate the mean of those numbers, you store them into a variable, let's call it A. And then what you would do, you would write mean, round brackets A. That is the input to your function, right? And you are going to get some output. So that was the default MATLAB function. Similarly, we are going to write our own functions. We are going to give input to the function, and the function is going to produce some output. So variables used in a function M file are unknown to the workspace if they are not specifically returned. I'll get back to this when I'm going to show you a function. So when you have a function M file that has only one primary function, and the convention is to name your M file, give it the same name as your function's name is, right? If your function name is compute statistics, then your M file name would be computestatistics.m, right? And then, yeah.
Is that like a procedure?
This is like a procedure, yes, this is exactly. And then you can also have some sub-functions. But the primary function would be just one function in the file, and you can have 0 to many sub-functions in that file. So let's have a look at primary functions first. Now we are back to the Newton's method. And here, in the example, it says that the solution of f of x equals to 0 of a general function may be solved by repeating the assignment, where x becomes x minus f of x divided by the derivative of x. So suppose we are trying to solve this equation, which is let me write this on the board. So the equation is x cubed plus x minus 3. So this is the equation which we want to solve. And then the first derivative of this equation would be 3x squared plus 1. Okay? Now, what we can do you can copy them using the recorded version of the lecture if you'd like to. So what we can do is that we can write 2 functions. One would be for f of x. Now what's happening here is that we are using the keyword function y equals to f of x, and whatever is below that line is in the function. And the second function could be df.m, which is going to calculate the derivative. Now you need to remember 4 things when you are writing a function. The first thing is the keyword function. Just like, remember, we had other keywords like for when we are using a for loop, or when we have the if-else constructs, then we have if and else, they are the keywords. So over here, function is a keyword. then the function has a return argument. So a function, you may perform a couple of calculations in your function, and then the function is going to return an output. So y is the return argument. And you have multiple return arguments. We have some examples later. And then the third thing is the function name. So df here, we are calculating the derivative. You can name your function anything, whatever you like to. So it's df here. And then the last thing is the input argument. So x is the input argument. Now we are working on this Newton's method using functions. So what we are doing is that, first of all, we have an iteration count. You guys have implemented Newton's method. So that's okay.
In a stripe.
Right. So you have the iteration counter, and then you have x equals input. So there should be an initial guess for the value of your function, right? And then you have a required relative error, which is RE, and then you can have some initial condition. It's just a variable. We'll see, because this would be the breaking condition later. So, and then you have a while loop, where there are two conditions, okay? So the first condition is that my rel should be greater than the relative error. This means that your relative error should be greater than the error which has already been defined, and the steps should be less than 20. So this program would run for 20 steps. And you know what is going on inside the loop. So so x old would be the first value of x, and then you are going to calculate the next value of x, calculate the error, and you would go on. So have a look at the sample output. Now, the initial guess was 1. So the disp function is going to display x and f of x. So the first one is 1.25. Then the next one is 1.214. And you see, the breaking condition is there, the MyRel condition. Okay, so when x minus x old divided by x, the absolute value is greater than the relative error, then we are going to break. So if you have a look here at the 13th iteration, the value is, that's okay, I don't want you to interrupt anymore now. So the 13th one is 1.2134 and so on. And if you compare it with the next one, that one is 1.2134, so on. And at that point, we find out that the error is, so this value is less than the relative error, and this is going to break here. So over here, what we were doing was that you need to remember only two things in this whole piece of code. And that is, you're calling functions. F of x and df of x, those are the functions which you are calling, okay? And you can also call the functions from the command line. We'll see, you can call them from the scripts as well. Okay, so this is another example of a function. Do you want me to show you some functions by writing a MATLAB code, or the slides are fine? Should I show some? Okay. Okay, so we have an example from statistics, a very, very simple example. So you have this function, Now, I told you to remember 4 things. The first is the keyword function, which is already there. The next one is your return arguments. Now, in this case, we have 2 return arguments, okay? One is the average, and the other one is the standard deviation. And then this is equal to mstats, which is the name of your function, and x is your input. Now, what this function is going to do is that is going to return the mean and standard deviation of the data in the vector x, okay? So we will test this in MATLAB in a bit. And also make sure that you do not have a function name which has already been defined in MATLAB, right? Have a name different than that. So this is a very small function. Now, the keyword would be displayed in a different color here, and mstats is the name of my file as well, mstats.m, okay? So I'm taking the average, which is mean of x. So these variables are my own self-defined variables, avg, let's say I'm just, yeah? Yeah, sure. I always forget it. It's good that you guys tell me. So where were the preferences? The other day somebody was telling me that she could not read the board marker, like the color was too light. So if you cannot read the board or the code, then do point that out. Is it okay? Okay. So this AVG variable, this is something I've defined myself, and I'm saying that this is equal to the mean of x, and stdev is equal to the standard deviation. Now, both of these functions, mean and std, they are already defined in MATLAB. So the first one calculates the mean of numbers, and the second one would calculate the average. Now let's say display it here. Okay, so we have a single column vector which has random numbers, and the length of the vector is 100. So let's call this function. Okay. So 100 would mean 100 means that I want 100 numbers and in one column. Okay. So make sure to put semicolons here, otherwise what your function is going to display the values after doing the calculation. So you need to suppress the output, yeah, if you like to.
What do you mean by one column?
Like this. These are the dimensions. This is what I mean.
So you mean between 0 and 1?
Between 0 and 1, and the dimensions are 5 times 1. Okay, so let's call this function now.
You mean 5 observations?
Yeah, 5 observations. So let's call this function this was the average and that was the standard diff. This equals to m stats and r. Now, okay, you need to note something over here. So, say in the function, the output arguments are avg and stdiff, right? Well, when I'm calling the function, I'm not using those arguments. I'm writing a comma b. That's perfectly okay because you want to get the result in something, right? And this is not accessible inside your function. So your function mstats is supposed to return 2 things, and they would be returned in this order, right? So whatever was there in the average one would go into A, and the standard stdiff is going to go into B, okay? And similarly, the input over there is x, but we are using that variable, unknown variable x inside the function. However, when I'm calling the function, I'm giving it another variable which is r, right? And this r would automatically get mapped onto the x, and then we are going to get these values, so average and your standard deviation. Is this clear? Right? See, this one was like pretty easy.
What's mstats?
This is your own self-defined function. All right, and then you can just simply display them using the display function. Over there, I did not use a semicolon. That's what, see, I did not use a semicolon here, so the output was not suppressed. And by now, I believe you know these things. So the general form of a MATLAB function is you need to have your the output arguments into the square brackets, as many arguments as you want, and then you have to write the name of the function and then the input arguments in round brackets. And you can also display comments. So if you write help your function, the comments will be displayed in the help. And we have discussed that the function file must start with the keyword function. However, comments may precede the keyword, yeah, like this. So you can have comments before defining the function, right?
We hit learn asshole, don't forget that. I don't care how much you pay.
So the input arguments, they must be separated with a comma, and they are enclosed in parentheses, right? And the output arguments, they must be separated by a comma or white spaces, and they must be in square brackets. Function names must follow the MATLAB rules for variable names. If the file name and the internal function name are different, the internal name is ignored. So in order to minimize the confusion, use the same name for the file and the function. I have told this before. And yeah, so we saw that in the example that the argument names are only dummy variables that are to be used in the body of the function. And when the function is called, other variable names and constant values, yeah, you can also give constant values and expressions for the input arguments. For instance, in this particular example. So see, I gave it R as an input. Let me try something else now. Right? So these are constant values. And they did produce a result. So they were mapped onto the variable x when I have called the function. So if there are more than one output arguments to be returned, the arguments must be enclosed in a square bracket. We saw we did include, we wanted 2 arguments and they were in the square bracket. Okay, now let's discuss what local variables are. Local variables are defined inside of a function. Okay, so you can define any of your local variables in your function file, and they would not be accessible outside. Okay. Local variables cease to exist after the function ends. For example, in this particular function, where you are calculating the power and you have 2 arguments, n and p, and then you have a for loop. Let me code this one for you. So I need this one and this one. Do you know how to tile windows vertically or horizontally? I can't do that, but that's okay. All right, so let's write this function. Create a new script. Okay, this is what this function is doing. And let's save it first. Now what I have done so far, I have the keyword function, then my return argument is R, and the name of the function is MPOW, and there are 2 arguments to the function, n and p. So R is 1 in the beginning, and for I equals 1 to p, R equals R times n. Now we are going to display the value of I. Okay, Control. Now in this function, this loop is going to run from I equals 1 to p. And remember, we are talking about local variables right now, and we have defined these variables inside the function. So I is defined inside the function. So let's say we have another I, which is equal to 2, and p equals to 4. And then we pass this to the function I comma p. Right. Now what happened was that that I was mapped to what? Let me see, there was a marker. So the function is I comma p. So this is the function which I'm calling. right? Whereas in the function file we have n comma p. So what has happened? This has happened. So now within the function, whatever value of I we gave to the function, now n is going to assume that value. Okay? And then this loop runs 4 times because the value of p is 4. And after 4 times, it's going to display this print statement, and it's going to tell you the last value of I, which is 4 within the function. Now let's see whether the value of I changed outside the function or not. So now here I'm on the command prompt, I'm outside the function. So the value of I is 2. It did not change. So whatever happened inside that local function, that did not affect anything which was outside. Okay? Now there is another thing which is called a global variable. So we saw that local variables, if you define them within the function, they are not available outside the function. And their values, so if there are variables with the same name outside the function, they do not get affected by whatever happened in the function with the local variables. So now we have something else which is called global variables. So you define them with the keyword global and then the name of the variable. So as the name suggests, they are global, they are ubiquitous, so you can use them anywhere and their values would change. So if several functions and possibly the workspace all declare a particular variable as global, then they share single copies of that variable, okay? So if I had been global, the value of I would be shared among all the functions. Let's say you have multiple functions. For instance, in this one, this function is, the return argument is R, and it is m times 2. There is no input argument. This is possible, just like if you call the date function or the clock function, they do not have any input. Similarly, in this function, there is no input. So you have a global variable k, you print its value, and then you do some calculation. So what is happening in the workspace is that k in the function times 2, right? So this has been displayed, and then after times 2, it's 4. And then when you call the function again, so the old value of k, you know, it remembers the old value of k, and then it works on the old value of k. So it's going to work on 4 now, and then k after times 2 is 8. So far we had a look at local variables and global variables. Now there's another thing which is called a persistent variable. So it's not really a local one or a global one. What happens with persistent variables is that you have them inside your function. So with that respect, you can say that they are local variables, okay? But the function remembers their values. So for instance, let's say k equals 2 is a persistent variable, and you have called the function 1, which has assigned it. Let's say we do some computations as well. Pardon? You were not here, so you have to catch up on the recorded lecture. So you have persistent variables. They would always remember their values. So if you call the function, if you call the function multiple times, that value would be remembered. For instance, in this one, we have a persistent variable count. Count equals 1, you are incrementing the value of count. So in the workspace, if you call the function test once, you would get this value of count 1 time. If you call it again, the value of count has been incremented. And if you do clear test, this means you are clearing everything which is inside that variable. So, and you call it again, then the value would be again 1. Okay? There are some other important details. If a function changes the value of any of its input arguments, the change is not reflected in the original input argument on return to the workspace. Hence, variables are passed by value. And a function may be called with all, some, or none of its input arguments. We saw that. We saw an example, and the same applies to the output arguments. And you can use the n-arg in and n-arg out to check the actual number of input and output arguments passed. Let's come to the sub-functions. In the beginning, I told you that there are two kinds of functions, primary and the sub-functions. So sub-functions may be declared in the same M files as the primary function, but they are accessible only to the primary function and other sub-functions in the same file. So what you cannot do is that if you saw that you can call a function on command prompt. You can also use a script and call your function like we did with mstats. But if you have another function in that file, then you cannot call that function, right? And that function is to be used by other functions in that file, okay? For instance, in this example, the primary function is your compound interest, which has 3 arguments. And then there is another function which is called interest. And this function is being used by your primary function over here. So f equals f plus interest times, right, f comma I. So
Compound interest is the same as simple interest?
later.
If it is 1 month?
I don't know. So now this is clear, yeah? So you cannot call it outside your function file. Now recursion. Recursion is a pretty interesting thing, and many mathematical functions are defined recursively. That is in terms of simpler cases of themselves, for example, the factorial function. So you remember how we can calculate factorial, right? Okay, let's see, try it here. So let's say we want to calculate the factorial of 5, right? So normally what we would do, right? This is how we calculate the factorial, but we can also write it like this. 5 times, what is this? Yeah, this is 4 factorial. Okay, and this 4 factorial, this can also be written as 4 times 3 factorials, and this would be 3 times 2 factorial, and this would be just 2 times 1. Okay? So when we are doing recursive programming, we make use of this fact. And recursive means that you are calling the same function over and over again. So in this particular function, you want to calculate the factorial of n. So what is the factorial of 0? It's 1. And this is your base case, remember? Okay? You have to remember these two things. You have a base case, and then you have a recursion function whenever you are doing recursive programming. So your base case here is if n equals to 0, then y equals to 1. In all the other cases, you are going to recursively call the function, right? In this case, your n was 5, so you are going to call the function with this is n, right? This is n. So you are going to call the function with n minus 1 factorial. And what will happen when you are going to call it with n minus 1 factorial? The the function is going to get this value that it has to calculate the value of 4 factorial. So the same function is going to be called again. You don't have to do it. It's going to happen automatically with 3 factorial, then 2, and then 1. And then you have this multiplication sign there, so eventually you are going to get your answer. And there are some other problems for which you can calculate, do recursive programming. For example, have you heard of the Fibonacci series? Right? So what happens in Fibonacci series? The first term is 0 or 1? I guess it's 1, right? So the first is 1, the second is also 1. Then it's 2, then 3, then 5, then 8, and so on. So you can calculate the Fibonacci series using recursive programming, and in that one, so your base case would be this would be your base case. This would be your base case, and after that what's going to happen is that you're adding the terms, right? You're doing 1 plus 1, which is 2, and the next one is 1 plus 2, which is 3, then 2 plus 3 is 5. So try this at home, try to calculate the Fibonacci series. So this would be something like this, f of 1 plus, the function would be something like this. So try to calculate it at home. Another alternative to functions is inline objects. They are a mini version of functions, and they are less powerful and less popular. But it's good that you know how they work. So what's going on here is that this function ht can be represented at the command line by creating an inline object, right? When? So that was the last slide. We are on this one now. So this is how you are going to define an inline function. You can give it some input. For instance, here the value of x is between 0 and 6 pi with increments of pi by 40. And then you want to plot it so that cos 8t plus cos 9t would get plotted. Let's leave that one. Okay. So the variable t in the inline definition of h is the input argument and serves as a demi-variable to allow input from the outside world. And it does not have to be called t when used. It's just like the functions, if you have those dummy variables. And you can also create functions of more than one argument. For instance, in this one, so x and y are your arguments here. And one can see that creating complex functions with inline, it gets very messy. So I would suggest you stick to the functions unless and until you want to do a couple of them for your own practice. And then let me summarize the lecture. So functions, they allow programs to be modular under the structured programming paradigm. And function M files are different from script files, right? And you have some rules like input-output arguments, and the scope of the variables has to be defined when you're writing a MATLAB function. So that is all for today.